Hi folks, and welcome back to another episode of Starting Sciart. Today we're going to be illustrating phototherapy. There are commonly two types, photodynamic therapy and photothermal therapy. A common type of illustration that is used is an illustration of a blood vessel surrounded by a bunch of cancer cells, carrier with the drug of choice, and then activation by light. And so today we're going to be illustrating part of that, in which we show this delivery and light activation of the treatment. It is quite common to have a further close-up image of the carrier releasing the drug, but today we're not going to focus on that. We're going to just create a general illustration just for fun of how these carriers enter from the bloodstream into the cancer cell and get activated by light. Just to point to some useful assets that are already available that you can use to draw that. There is obviously the whole collection of assets from CG Figures, which includes a cell membrane builder, so you can use that to create the commonly used secondary part of the image, which is the cross-section of the cell, showing what's happening inside. So let's get started. So as always, starting in a blank scene, I have my default cube and background, and this time we're not going to delete the default cube, we're going to use that to create our cancer cells. And we're going to use geometry nodes to create an individual cancer cell and then distribute a bunch of them into an array. First off, use our default cube and call this a tumor cell. And let's go ahead and open geometry nodes. Let's create ourselves a new node tree and call it tumor cell. And even though we didn't delete the default cube, we are going to delete it here. So go ahead and disconnect the input geometry and look for a UV sphere. So what we're going to do is use geometry nodes to create a warped UV sphere, and then we're going to apply some shading to give it a little bit more interesting texture. So first off, we're going to need to add a set position node, look for a noise texture, and essentially the operation we want to do is move each of these faces by a certain amount along their normal dictated by this noise texture. So go ahead and look for a normal node as well as a vector math node. Set to add. Go ahead and plug the normal into one socket and the noise texture into the other, and take the vector output of the add into the position. And once you do that, you'll see that you get a very scrumpled looking UV sphere. So the first thing we're going to do is actually accommodate for the fact that when we apply the noise texture, it shifts this whole UV sphere by 0.5 actually in X, Y, and Z directions. So we need to first subtract 0.5 from all the directions to recenter the sphere. Next, let's actually play with the noise texture. So right now the scale is too high, and so you basically have the scale being comparable or smaller than the spacing of the vertices. So let's drop that to something like 1. So we get a very gentle undulation of the UV sphere. Let's go ahead and add a set shade smooth. And so you can change the look by controlling the properties of the noise texture. If I go ahead and play with the detail and the roughness, you can get different shapes. I'm not looking for something that looks too angular or sharp, so I am going to up the detail. I might even lower the scale even further, maybe something like 0.5. If you wanted to look for different iterations of that, go ahead and select 4D, and you now get this time option in the noise texture, and you can use that to sort of play through and look for the shape that you want. I'm going to just add a transform geometry right at the end, and I'm just going to scale it down by adding a value to the scale node, and let's finally add a set material node. Let's go ahead to the material options and create a new material, call it tumor, and select tumor in the set material node. So we're going to need to apply some textures. Let's temporarily come to the shader editor and have tumor selected. So for this illustration, I'm going to go for a slightly bluey, purpley base color. So you can choose whatever color you want. I also want it to be a little bit reflective. So I'm going to drop the roughness to 0.2. Next, I'm going to add some further surface textures by applying a bump node in the normal socket. On the height, look for a noise texture. And if you plug that in, you can already see that the noise texture is starting to create these funky looking textures on the surface, so that it's not just a plane of smooth shading. At this point, I should point out that you should have the Node Wrangler add-on enabled. If you haven't, it's the usual edit, preferences, go to add-ons, and make sure you have Node Wrangler enabled by typing Node Wrangler, and just tick this checkbox here. So with Node Wrangler enabled, select the noise texture and press Ctrl T to add a texture coordinate and mapping node. Make sure you select the object coordinate rather than generated and plug that into the mapping. And so now you can basically create some kind of warped surface imperfection texture by playing with the scale of the noise texture. I'm going to keep this quite high in scale value, maybe something like 30. Let's crank up the detail to maybe something like 8. And right now the bump is really strong on this guy, so you can change that by lowering the strength of the bump texture to 0.3, and that's looking pretty good for me. So this is going to be a very, very artistically styled tumor cell. The next thing we're going to do is create a geometry on which we can spawn a bunch of points and distribute a bunch of these tumor cells to create a bed of tumor cells. So let's hide the tumor cell for a second, come back to solid view, and I'm going to add a UV sphere. And this UV sphere I'm going to call tumor cell distribute. Let's come into the side view and tab into edit mode, toggle on X-ray view, and then select the face select mode. Go ahead and select all of the bottom sets of faces. So with the X-ray mode enabled, you can basically select everything that is in line of sight. With all of the faces in the bottom are selected, press X and delete all the faces. So now I have myself a semisphere. I'm just going to scale that semisphere down in the Z direction, also maybe in XY, and make sure you press Ctrl A and apply scale. So with the tumor cell distribute object selected, let's come back to the geometry nodes editor and create a new node tree, and let's call it distribute tumor cells. And this is a really simple operation. We're just going to distribute a bunch of points on faces. So distribute points on faces and instance on points, and into the instance socket, look for an object info node, take the eyedrop and select the tumor cell. And so that should allow you to instance a bunch of those tumor cells on the surface of that semisphere. And so that semisphere is basically just acting as a scaffold to distribute all of these tumor cells. A couple of things to change. The first is that they are currently intersecting with each other. So instead of random on the distribute points on faces, you can select pass on disk. And that allows you to control something called the distance min, which allows you to set a minimum distance between the points that are distributed. Obviously, a minimum distance of 0 means that they can lie on top of each other, hence you can start to get these coming too close. But if I set that to something a little bit bigger, like 0.2, you can start to see that I can keep all of the points at a minimum distance. In this case, the tumor cells are all a little bit too big, so let's go ahead and into the scale socket for the instance on points, look for a random value node, change vector to float, and this just allows you to randomly scale some of these tumor cells. I might do something like 0.4 and 0.6. I'm going to need to go back and lower this density min now so that I can actually pack these guys sufficiently. So go ahead and play with the values until you get a reasonable looking spacing. Also, to make this look a little bit more interesting, I'm going to randomly rotate these tumor cell instances so that they don't all lie pointing in the same direction. From the rotation socket, look for a random value node, keeping it to vector. Let's at the minimum stay at 0, and the max let's set to 2 pi. And so that just basically rotates everything about 360 degrees randomly for each instance about all 3 axes. So I'm just going to play with some of these values, the distance min, the density, and the scaling to create a fairly densely packed bed of tumor cells. So if I just come into rendered view, this is what we're currently working with. I think that's looking pretty decent. So now that we've distributed our tumor cells, let's go ahead and mock up the blood vessel that's meant to sit on top of it. I already have my blood vessel asset sitting in my asset browser file directory. So all I need to do is come to the asset browser, and here it's already listed as artery. So I'm just going to bring that in by dragging it into the scene and dropping it down. I'm just going to create a collection of the blood content in the artery by pressing M, new collection, and I'm just going to call this the blood vessel. So now let's just position this blood vessel so that it sort of drapes over this bed of tumor cells. All you need to do is select the blood vessel, tab into edit mode, and just move the object entirely in edit mode. And so now it's just a matter of moving the spline handles for the blood vessel, moving them around to sort of have it conform to this mound of cells and just sort of drape themselves over. You might need to add a couple more spline points by selecting the 2 endpoints to segments and subdivide, maybe one more time, subdivide again, and that should give you some more handles on which to control the spline. Something that you might find useful is proportional editing. So if I click this button here for proportional editing, keeping the smooth function on, you can use that to increase the distance over which the, say, transformation is applied. So if I wanted to move just this spline point, but wanted to bring the rest of the geometry with me, I can use this sphere of effect to control how much the neighboring geometry gets influenced by this operation. So you can use that to more controllably change the shape of the blood vessel. I'm also going to extend the blood vessel by pressing E and extruding, increasing the length of the base spline. I'm just going to extend the back plane a little bit to give ourselves more space. So there we have a blood vessel draped over some tumor cells. At this point we need to make a couple of tweaks. The first is that it's starting to clip some of the uppermost tumor cells, and we can fix that by clicking on the better tumor cells, coming to the modifier tab and to the geometry nodes modifier. Just disable that from view right now. Make sure it's still enabled in render, and I'm going to come into edit mode for that semicircle we're using to template all of those tumor cells with edge select mode enabled. I'm going to hold down Alt and select some of the edges. I'm also going to select the opposite side of edges with Shift Alt and selecting those as well. With proportional editing still enabled, I'm just going to press G and Z. I'm going to depress the semicircle a bit in the region under the blood vessel. And so if I now come back and enable the tumor cells, I've just basically created a little recess for the blood vessel to sit a little bit more nicely. So go ahead and sink the blood vessel properly in there. And I think that is probably looking pretty good. Before we move on to the next bit, which is to add some finer capillaries branching out of the blood vessel and sort of wrapping themselves around the tumor cells, I'm just going to increase the number of cells in this little mound by just duplicating this entire tumor cell distribute object, moving it down in the Z direction, and let's just rotate it a bit along the Z axis as well, just to give it a bit of variability. So for the next step, we're going to create a bunch of smaller capillaries that will branch out of this main blood vessel, sort of wrap themselves around the tumor cells. Just before that, let's go ahead and combine the tumor cell distribute into a collection called tumor cells. And I'm also going to take the tumor cell itself and plug that in there. And so now we can just use the visibility of these collections to toggle them off. So to create the finer capillary, let's go ahead and add a Bezier curve. Create a new node tree on the geometry nodes and call this capillary, and this is going to just be an operation of converting this curve to a mesh. And let's go ahead and apply a curve circle as the profile curve, and let's select fill caps. So the effect that we need to create is a taper in radius. So we want the radius to go from something like 0 at the tip of the capillary and then come back to something non-zero further down the curve. And so to do that, we need to apply a set curve radius node before it gets converted to a mesh. Go ahead and look for a spline parameter node, and you'll also need to add a resample curve node. Let's just crank up the resample to something like 50. That just gives us enough points on the curve to play with. Next, we're going to take the factor output from the spline parameter and just plug that into the radius. And you can see we got ourselves a very interesting looking shape, but it is roughly the effect that we're looking for. So if I look from the side, we basically just have a linear increase in radius moving along the spline. Now we can do two things to control this a bit better. The first is a map range node, which I plug after the factor, and so the factor, which goes from a value of 0 to 1, we can make that more or less by changing, say, the maximum value. So if we wanted the taper to be more gentle, we can just lower the max value, so it goes from only 0 to 0.3. Let's say we actually wanted to change the shape of how this radius changes, something that is not linear, for example. So for that, we need to add a float curve node and plug that in after the map range. By default, it has a linear gradient depending on the factor. But if I, for example, point and use that to start messing with this, so it's not linear, we can start to create different types of gradients. So let's also add a set material node right at the end. And let's go ahead and select the material that's used on the outermost layer of the blood vessel. In this case, this happens to be the tunica externa. And so now we have ourselves a procedural capillary that we can append onto our blood vessel. Let's go ahead and bring back the tumors and the blood vessels. So I'm now just going to go through a process of moving this capillary we've just created around, duplicating a bunch of times and creating a network of capillaries. And so again, just as we did for the blood vessel, I'm just going to use the control points for the spline to bend the spline around to sort of wrap around the tumor cells. You can add, again, more segments by using the subdivide function to get a little bit more control, as well as using the proportional edit to sort of bend it a bit more naturally. This is a little bit laborious, so let's just fast forward this step. So I've added a couple of smaller capillaries as well. Let's change quickly the material that's used for the blood vessel and capillaries, i.e. the tunica externa. Come to the shader editor, select the tunica externa. So right now it's an extremely rough material with some subsurface scattering. For this illustration, I'm not going to have the subsurface, so let's drop that to 0. And I'm also going to give this a little bit more of a shiny look to sort of match the look of the cancer cells underneath. I'm also going to play with the noise texture for the bump that's currently applied. Let's drop the scale down to something a little bit smaller so we get more obvious surface textures going. And let's maybe increase the strength to something like 0.2. So that gives us this kind of a look with a bit more surface texture to the blood vessel. So before we move ahead, let's just do a little bit of housekeeping. So all of these Bezier curves here are our capillaries. So I'm just going to select all of them, press M, and put them in a collection called capillaries. So now everything is nicely tucked away in our own collection. So you can add whatever drug delivery carrier that you want in the bloodstream. Just all you have to do is just add it to the blood content collection. I'm just going to create a very generic looking micelle, create a UV sphere, not have it inside the blood content, otherwise it's going to instance everywhere. I'm going to take it out of the collection. Just call this drug carrier. Let's scale it down. Apply scale, and let's just give it a new material, and let's call it drug carrier. I'm going to make it a very visible green, something like this. And I'm just going to apply shade smooth. So here, all I now have to do is, for example, add the drug carrier to the blood content. You got to just make sure that the object is actually sitting in the origin. If, for example, you didn't want these other blood cells, platelets, and you just wanted the red blood cells, you can just delete those out of the collection and pull them out. Maybe that will simplify the illustration a bit. And so now you just have the drug carriers together with the red blood cells. So to create the beam, I'm going to just use a curve path object. And in the geometry nodes editor, let's create a new node tree. Call this the light beam. Let's go ahead and look for a curve to mesh node and set the profile curve to a curved circle, trusty curved circle, fill the caps. And this is going to be a really fine beam of light, so you don't particularly need a high number of points for the cross-sectional resolution. Even something like 6 is okay. The radius, down to something really small like 0.01. Let's go ahead and rotate this and translate it into position. And at this point, it's probably a good idea to set the position of the camera. I'm going to have the camera look down from this kind of perspective, move the viewport around until you like the look, then come to view, align view, and align camera to view. So this is what we're currently working with. The background is clipping just a little bit here, so I'm going to go ahead and just move that in the X direction to fill up the frame. So coming back to the light beam, let's just bring this back into view. Go ahead and rotate that by double clicking R for free rotation and just move it into place to roughly where you want it. Might be good to have it on the far side of the collection of tumor cells. So let's put it somewhere here. Might also play with the camera, adding a shift in the X direction and also in the Y, just so we have the beam having a little bit of space in the image. Let's then, with the beam object selected, let's also add a set material node, create a new material, and let's call it beam, and select beam. Come to the shader editor. So obviously the simplest beam material you can do is, if I just delete the principal BSDF, I can obviously apply a emission shader and plug that into the surface, and I'll just uniformly light up this object. So I can crank up the strength like this. To make it a little bit more interesting though, I'm going to break up this object so that it emits in certain places but not others. So go ahead and look for a transparent node and a mix shader. Plug the emission into the second socket and the transparent into the first. Now look for a noise texture, a color ramp node. Connect the color output of the color ramp to the factor and the factor of the noise to the factor of the color ramp. Select the noise texture, Control T to add a mapping and texture coordinate as we did before. Something we need to do, select the object texture coordinates and plug it into the mapping. So if I view the output here, let's crank up the scale to see what we're doing. You can see that we have the noise texture mapped along the beam object. If I bring in the black and the white handle of the color ramp, I can basically create regions where it will just be transparent and there will be no emission, and bright regions where it will be. If I come back to the mix shader, let's maybe change the emission to something orange. So now you can see I can create these patches of brightness in the beam to give it a little bit of discontinuity. Obviously this is not physically real. This is again for just artistic purposes. And again, play with the detail and the roughness in the noise texture to give the light texture that you like. I'm just going to have this guy come in like this. You can have this beam impinge wherever you want. To give the scene a little bit more interest, I'm going to add a empty, and I'm going to use this as the focus object. select the camera, come all the way down to the depth of field and select the empty as the focus object. And so obviously how much defocusing you do depends on the nature of the image. If it's just a figure for a paper, maybe not so much defocusing. I'm going to take artistic liberty here and let's go for something a little bit aggressive. Maybe something like 0.8 will make the scene pop a little bit more. And so I encourage you to sort of play around with the position of the camera, the position of this beam, but that is basically it for this tutorial. So if you found this useful, please leave a like and a comment, particularly a comment on other things that you'd like to see illustrated in this series of Starting Sciart. Please subscribe for more content like this, and I will see you all next time. Bye bye for now.